Here we go, guys. All right, so we're going to look at binomial distributions, example 2, part B. I would again suggest you watch these in sequence. Part A set up a lot of the elements of this. So it talked about we're going to survey 20 people. The question in part B does mention being left-handed. So once again, being left-handed is considered success. And success can be defined either way, depending on whoever wrote the question. And it said that 1 out of every 9 Americans is left-handed. So that P is 1/9, and therefore Q would be the opposite of that, 8/9. Binomial experiments only have 2 outcomes, and so the P and the Q have to add up to 1. So just keep that in mind. All right. Now, if you survey 20 people, you could have anywhere from 0 to all 20 of them be left-handed. I suggest using this visual over here to help you reason out these questions. I find that extremely helpful for me. All right, so when we look at this, and it says find the probability that the number of left-handed people, X, is at least 1. All right, let's put the number 1 in there. Well, again, if you look at this range of numbers, that number could be anywhere from 0 to all 20. I hope you would agree that at least 1 would be all the numbers from 1 clear up to 20. All right, and so much like we did on example 1, when we say at least 1 of something, we're saying what? Greater than or equal to 1! That is right. Good job. I will give you, I don't know, maybe we'll give you away prizes here in a little bit. But anyway, greater than or equal to 1 would be corresponding to at least 1. That's all the numbers from 1 to 20. Here's one way a person could do this. We could set up the probability that 1 person is left-handed out of 20. That would be its own setup. Or plus 2 people, or 3, or 4, or 5, or 6, or 7, or 8, or 9, or 10, or 11. I'm tired. You can do that all the way to 20. That will work. Party at my house. Actually, no. We're not supposed to do that. But you get the point. That's a lot of work. Just like we talked about on example number 1, when you have a wide range of numbers being described in the question, a person might look at this and say, you know what, if you found all the probabilities for every number from 0 to 20, this should add up, all those probabilities should add up to 1. That's a 1 I'm drawing down there, 100%. Oh, you know what? The opposite of at least 1 is to not have anybody in the group be left-handed. 0 of the 20 people are left-handed. Once again, it would make sense to do the complement here. So the idea here would be that we'll determine the probability that 0 of the 20 people are left-handed. And since that's the opposite of the original question, the complement of the original question, wouldn't it make sense to take 1 minus that, and that would equal the total of all those probabilities for the individual numbers from 1 to 20. Yeah, that's smart. Let's do that. Okay, so here we go. 1 minus, and here we are. Hey, pollster, I'm going to give you 20 people. You can choose any 0 of them to be left-handed. I do not care what order. That's why that's a combination again. I want to remind you that that's combination of 20 choose 0, same thing. But I like the parentheses. All right, and then left-handed has a probability of 1/9. And there would be 0 people in that group that are left-handed, which means that right-handed, 8/9 would be all 20. You crunch that out, that would be this entry in the table, and you take it away from 1 to get what those others would have added up to. That's what you call smart, all right? And I'm not always smart, but I think that made sense on that one. I went ahead and did all the math on this. If you crank this out with your magic box, your calculator, and subtract it from 1, you will find that the value you end up with is 0.90516917018675309. No, wait, that was a shout out to my wife Jenny. But anyway, there you go. Be my guest if you would prefer to set up these probabilities for every number from 1 to 20 and add them up. It should come out the same. I'll give you that choice. Anyway, we'll be right back here to do parts C and D. We're going to do them together. Thank you.